that's it for our products, really, except for...
We're going to do what everybody's really excited about, and I'm probably overly excited about it. 48 volts. So I'll give you a little bit of history. So we had, these were going really well, and we were having a fantastic response. And so we thought, okay, perhaps we've solved one big problem. Okay, what's the next big problem? We discussed it. And what's the next big problem with electrical and camping is charging the battery. You can have the biggest set of batteries in the world, but you've got to get the energy into the battery. So there are two ways of doing it. You do a soft charge, which is driving, and solar. In Australia, they call it soft charging. Or you can go to hard charge, shore power. That's a problem. I don't want to go shore power. I want to stay on the road. But now I have to keep moving because solar, up to a point, supplements everything. If it's nice and sunny, it can even do everything. But if it's not sunny, then it becomes a challenge. And I have to modify my use of the electricity, my use of energy, according to what my solar, how well it's doing. Or I must go driving. So we decided that the next big challenge was, how could we make the charge from the engine alternator really, really fast? And Heiner's conclusion was, well, with 12 volts, the best 12 volt could do with a really beautiful system, high end, getting 100 amps into that battery, that charge is about as much as physics will allow 12 volts to do. No, that's not enough. All right, we have to increase the voltage. How do we increase the voltage? Well, you can add an additional alternator, a 48 volt alternator, because we spoke about 24, which would give you a give or take a little bit, about twice. Great. But how about 4 times? 48, because 48 volt alternators are available. So then the next thing was, okay, well, sounds easy, right? Now there is a big catch, and Heiner will explain there was a big catch. 48 volts, we've got alternators, but we've got a problem.
Massive problem.
Massive problem.
48 volt systems can have something that is called a load dump scenario. And if you are familiar with plumbing, you can get water hammer in plumbing lines. So it means if there's a lot of water flow and you instantaneously shut the tap, there's going to be a back and forth of that energy that is in that water line. The same happens with electricity. So if you fit a 48 volt system and you're charging 5 kilowatts into your lithium battery, and for whatever reason, the battery management system shuts down, a lug falls off, something happens that the charge can't go anywhere, you can expect to see 300 to 400 volts on that line as electrical water hammer. That also means that anything connected to it will pretty much fry in an instant, because these load dump scenarios last for about 200 to 250 milliseconds, and it's the field in the alternator that has to be shut down to make sure the alternator stops producing energy. And if it can't go anywhere, it will just create massive pressure or voltage spikes. And there's nothing available in the industry. In 12 and 24 volt, it's done internally in the alternator with something called avalanche diodes. But they only exist up to 40 volts, so they're no good for 48 volt systems at all, because we charge at about 56.8 volts into the batteries themselves. So what we've done is we've designed this bit that is actually taking care of the load dump scenarios. And when we installed it for the first time...
No, I've got to show you. Who saw the video of the thing exploding?
I'm nervous. 3 years of R&D and planning. Oh shit.
That wasn't good. It was up here. Okay. So what that was the load dump scenario protection unit working, but there was a problem.
It only worked once.
It only worked once. So we froze. What are you thinking? Because we now had to drive right across Australia testing this unit, and there was a lot hanging on it. So, the reason why it happened was as you were putting in the fuse, you were a little bit nervous and you were kind of a bit scared about this.
I was extremely nervous and I was shaking.
He was shaking and the fuse touched, it came away and it touched again.
And it sparked and that created voltage spikes. And the load dump protection unit went activated, but it didn't deactivate anymore. And when it activated, what it does is it short circuits battery positive to battery negative. It's supposed to do that about 200 times in about 200 milliseconds. When the voltage rises past 68 volts, short circuits it until it's back to 60 and it gets rid of the excess energy.
This is the protection against surges in the 48 volt side if the alternator has got a load dump scenario.
The problem was it stayed active and it short circuited the battery, and the battery pumped about 5 kilowatts of energy through that little unit, and it did that for about 1.5 seconds and then it exploded. So and from that it was back to the drawing board for us to actually redesign that system, which we've done now, and we've tested it. We hooked the system up, put oscilloscopes to it with the electrical design engineer we're working together with, and what we did multiple tests where we ramped the charge current up to 5.5 kilowatts into the battery and then used the BMS switch on the battery to turn it off instantaneously. So we could trigger load dump scenario events like you never want to have in your system. And that unit short circuits these load dump scenarios all the time now. Activates about 180 to 200 times within 200, 230 milliseconds and keeps the voltage safe under 68 volts to make sure that none of the 48 volt equipment connected fries. And because that is not enough, because I don't like to just have one critical system, we put 2 more high voltage diodes on there. They react at a higher voltage and they can take 5,000 watt for about 10 milliseconds roughly. And if the voltage spike is really fast and extremely fast transient, these diodes will kick in first before the load dump scenario kicks in. So we put multiple safety layers in there to make sure load dump scenarios cannot happen with the Egon 48 volt system. Another thing that I think is really important to note here is that system charging 5 kilowatts from the alternator directly into the battery. That means the equivalent of a 400 amp DC-DC charger in 12 volts. So what it means is if you've got a 400 amp hour 12 volt battery, you only have to drive for 1 hour with this system and it's charged from 0 to completely full. That is something with 12 volt is absolutely impossible. Another thing is that a lot of people have asked, oh, how much more fuel does it actually use? Now, that's the cool thing. If you charge a 10 kilowatt hour battery, which is 2 400 amp hour 12 volt batteries, on an average diesel engine, you save about 1.5 liters of fuel by using a 48 volt system, because the problem is voltage drop again, and losses in a system are not just linear, they are exponential. What that means is if you up the voltage 4 times, you reduce the current 4 times, but it actually increases the efficiency of the system 16 times over. So if you've got a 400 amp system on 12 volt, you've got about 2,000 watts of losses to the battery. If you use the same system in 48, you've got about 250, 260 watts of losses. That is one of the reasons that we went up so far with the voltage, that we could actually get systems to run efficiently on higher charge currents. It also enables us to use the alternators as direct replacement alternators, because if you want to try to put a 5 kilowatt 12 volt alternator in the same space that your 1.8 kilowatt factory alternator operates in, the losses in that are so immense that the unit will just fry. It's impossible. You probably have to add liquid nitrogen cooling to those alternators to make sure that they don't fry out, which is, again, not really possible in the field. This is the system layout. This is the proposed design for a replacement alternator system. There's another system where we leave the 12 volt alternator in and we just add a 48 volt alternator. That is an even more reliable system, but I explain redundancies in a minute. So the way this works is you've got the Egon hub as per usual, the central unit that connects everything together. Because with 48 volt, even though it's relatively simple, you still have to have a lot of knowledge on how do you actually regulate an alternator? How do you make sure it doesn't overheat? What do I use? How do I program it? Everything that you need to know is how do I connect this unit to the board? How do I connect one of the Egon alternators, and we'll be supplying alternators that will be compatible with our boards? And how do I connect the Servo GX to a board? We will be supplying harnesses for that in the future. And the way you do that is you'll have a harness that's labeled for this unit 1 to 8, and you'll have numbers on the board labeled 1 to 8. And that's as much as you really need to know about this. And you do the same thing for the Servo GX, labeled 1 to 6, alternator labeled 1 to 4. And all you need to do is 1, 1, put together. That's it. So we really wanted to reduce the complexity so that 48 volt systems are possible to install by workshops that are not electrical engineers. Because eventually I think this is the way this industry will go. Not right now, but it's slowly building. And in Australia, we can see that there's a lot of uptake. We had massive influx from workshops, from people that are saying, oh, we're just doing a new build. We want air cons to be running, air fryer. The industry has shifted, I think. When lithium batteries came around, it was a bit like when combustion engines came around for the transport industry. We used to have horse and carts, and then combustion engines came around, and we used to have cars eventually. Now people, because of lithium batteries, can live off-grid. A lot of people in Australia sell their homes, they buy a caravan, they buy a big truck fit out, and they say like, well, there's no need. We shouldn't have a house anymore, because in summer we're in the north and we're in the south, and in winter we're in the north, and we have a great life. Why have a house? Because they can have all these luxuries. They can have air cons running. They can have a washing machine. All these things that you want to be comfortable is possible, but the limiting factor is the recharge time. Because you can have, like Andrew said, you can have a 10,000 amp hour lithium battery bank if you can carry it somehow. It'll still be empty eventually. So the key component is not to have bigger battery systems, but to have faster recharges for these battery systems, which will then allow you to run with less battery capacity, save weight, be more flexible with these sort of things.
I think it might be worthwhile, because a lot of the questions we got was, well, what about my 12 volt systems? How do they work in this whole scenario? So very basically, you have an alternator that charges the house battery. The house battery has a converter that feeds the car, and it runs the car. The house battery is being charged not only from the alternator, but also from the solar. So in effect, if you've now got a full house battery, you've got some solar on the top of your caravan or vehicle, okay, you can actually disconnect this, because the solar is charging your house battery, and your house battery is running the car and charging the start battery. We're going to do a big trip this year with the van. We're going to have 600 watts of solar on the, about 600 on the roof.
Hopefully 800. We'll see. Hopefully 800.
We're going to try, but we'll have at least 600. And we are going to do part of the Canning stock route, but with no alternator at all, to prove a point that the redundancy systems in it, even if you lost an alternator and you didn't have solar, you would have to empty this battery and that battery. We worked out that we could drive, give or take, 24 hours before running out of energy. But if we've got solar on top and the sun's shining, we could drive the whole trip without even thinking about it. So that's the redundancy. But if we want to run our air cons in, that'll work.
Yeah.
And it'll charge very, very quickly, and then we can...
And the way we're doing this is, when you look at these units here, these are either 48 to 12 or 48 to 24 volt converters. They are being switched on through this circuit board. The circuit board gets energized through an accessory input from the vehicle itself, or you can use the relay contacts in a Servo GX to override it and keep these constantly on. That means that you have now got a 100 amp charge circuit to your start battery. And that is what is being used to power your vehicle while you're driving. But the cool thing is, if you're at a campsite and you want to run your stereo, you want to leave the headlights on, whatever you want to do, It's very counterintuitive, but the best thing to do then is put the key into the ignition and put the accessory circuit on, because now that will make sure that your start battery stays fully charged all the time. Or you just override it in here, and you've got constantly, it's almost like having a solid state alternator. And all you need to do for the installation side of things is where your 12 volt alternator used to sit. You deinstall that, put the 48 volt alternator in. You only have to run a 16 mil cable, and we recommend a twin core cable to put the 48 volt circuit into the board here where the alternator input is, and you use the other cable to feed 12 volt back to where your 12 volt alternator used to feed into the vehicle system. And that's it. That's your conversion done. Now you can charge, or now you can use the power stored in your house battery to always top up your start battery. And while you're driving along, this battery here, through the alternator, will be supplying your vehicle. There's a second unit here that you can use to then hook up something like a power distribution system, like a relay hub, or whatever else you want to use for a 12 or 24 volt power distribution system to run fridges, lights, whatever else you might have.
Can I talk about the trailer idea?
Ah, yeah, if you...
To me, it's the most exciting. Can I... So, who pulls a trailer? Who pulls a big caravan? Okay, here you go. This is perfect. All right. So now you drive and you've got your 48 to 12, and that is in your trailer. So you've got a cable running 48 volts, minimum losses, all the way to your trailer battery. You've got a 100 amp charge at in your trailer. So you arrive at your destination and your car battery is full, definitely, and your trailer battery will be full. Fantastic. Now you're sitting there 2 or 3 days. You got a bit of solar, but whatever. Okay, and now you go on a game drive. So you disconnect, and while you're game drive, this is charging this incredibly fast. You'll go on an hour's game drive. That can be at 10% charge. You'll go for an hour's game drive. When you get back to your car, that's at 100%. You plug it back into your trailer, and the charging circuits turn on, and your trailer gets recharged. So your car becomes
a generator.
Because the charge is so fast, a small game drive will be enough to recharge it and recharge your trailer for a 1 hour game drive.
And the good thing is you don't have to run the engine at camp, because 48 volt being higher than 12 volt, there's no need to run the engine. The 48 volt will automatically flow into the camper trailer or caravan, and it can be 12 or 24, it doesn't matter. We can have these converters supplying 100 amps into that battery. And but they will only supply up to 13.8 volts. So you have the last little 10% still not fully charging. But what you can do quite easily is, instead of using these converters, you could put a 100 amp maximum power point tracker in there, a solar regulator. Because a solar regulator can easily take up to 100 volt input, and it will use the power from this battery, treat it as a solar panel, and charge flat out into your caravan battery. And all you have to do is plug a plug-in and transfer load from your vehicle into your caravan or camper trailer. And because to actually run a 100 amp charger on the 48 volt side, you only have to transport 25 amps at 48 volt. So you could use a 6 mil cable. Sorry, what do you guys do? Yeah, 6 mil cable, what you would call it here, because that's good for up to 30 amps. And you can use that to have a 100 amp charging circuit in a trailer. If you want 200 amp, well, you can use an 8 mil cable or a 10 if you really want to go over the top. And you can get 200 amps charged into a camper trailer or caravan. And when you install this system, in terms of power distribution, you can easily run, this is a 6 kilowatt inverter, it's a RS6000 Victron inverter, and you can hook that into the circuit board itself. All that takes, you could do it with 16 mil cable, but I would say go a bit over the top and use 25, and you can run 6 kilowatts out of that inverter. That is less than half the cabling size that you would use for a 12 volt 3 kilowatt inverter. So the weight saving of these systems is going to be massive in the future. The cost savings are going to be massive because copper is quite expensive. And the efficiencies are absolutely non-reachable with anything on the 12-volt market. If in the future, and it's slightly happening in Australia, there are a few manufacturers that are already building 48-volt caravans, there will be a charge system you can retrofit as a secondary alternator. So the alternators that we've developed are vehicle specific except for one unit. One unit we've used and designed it in a way that it's got a send-in air conditioning compressor mount. That is the most used compressor in refrigerated transport. And everywhere in the world, there's add-on kits for secondary air conditioning compressors for refrigerated transport, for whatever you use, meat transport, fresh produce. And we can use these brackets to add a secondary alternator instead of aircon to the belt drive system. They're easily strong enough because these air conditioning compressors are operating at a fairly high kilowatt level as well. And then we can directly run a cable to a camper trailer or caravan, have a few control cables like temperature control, because this unit here controls the temperature of this alternator. So if it gets past 95 degrees, it derates to make sure the alternator doesn't fry out. It's adjusting the field and it needs an accessory circuit back to the van. So you need altogether 6 cables and you can have a 5 kilowatt caravan charging system, and you can easily replenish your batteries without ever plugging in.
So really, in many ways, shore power becomes a thing of the past, because by the time you get to the shore, you're fully charged. So that's the idea behind it. And it's working. We've got them out there in the field now being tested. So we're only launching this in April, but we've got 3 vehicles out there now being tested and another two being built now. So, and it's working. It's working.
On my vehicle, you saw the fusible ring problem out there. If I put this system in, does that mean it takes the load of the factory wiring? You will not have that problem with the fusible ring.
Yes, but for the amount of battery storage that you've got, to recharge that from 0 to empty, it's a 20-minute drive. So it's a bit over the top. I only recommend these systems if you're actually using a fair bit of power. If you want to run an inverter that is fairly large, or if you want to run a battery bank that's huge and the customer will have to drive 10, 12 hours a day to recharge them, that's about the time when you think about 48-volt systems. If you've got a very standard system where the customer wants to run a fridge, a few camp lights and recharge phones, it's not necessary. You run your engine for 10 minutes to offset a 24-hour energy consumption. Of course you can do that if you really like to do that, but you're probably wasting a bit of money because a 25 amp DC-DC charger is probably quite sufficient for the job. So there's a right tool for every job, and this is definitely more for bigger systems. All right, guys, this is most likely, I think, the end of our presentation. If you want to get more information, talk to our partners from Tricara. They run the egon.com.za website here in South Africa. And they can help you with Egon installations. You can source products directly through them. Ian, if you want to say a few more things.
Yeah, so as I said, we carry local stock, so everybody wants to recharge. We look at the products we have locally. We've got installers that are skilled up and trained up locally as well. We do installation ourselves, so and we're obviously in touch with Heiner who constantly about various product developments and any technical questions you may have. One of the things we didn't go through was more along the planning side.
Correct, yes.
To installers.
So this might be interesting for installers of our systems. What we offer is, if you come on board as an installer and you've got your 2, 3, 4 different systems you generally install, send us through a component list. I will compile engineered wiring diagrams, cable sizes, fuse ratings, and I'll send you back PDFs of these wiring diagrams. So you can then standardize what you do in the workshop, and even better, you can hand these out to the customers and say, look, this is your system. And that will really set you apart from your competition, because who else supplies wiring diagrams with installations and says like, look, these have been engineered You can trust the system that we've installed. So that's part of the program. We call our group of installers worldwide, we call it our Renegade Network of Installers. If you become part of that, we offer this service for free to you.